An M cable is generally prohibited from being embedded in Adobe. However, it can be permitted in contact with Adobe if the Adobe is not likely to be disturbed and the cable is protected from physical damage. There are several additional considerations when using an M cable in Adobe construction. Firstly, the Adobe material can contain moisture, which can damage the NM cable insulation. Secondly, the Adobe can be susceptible to cracking and shifting, which can put stress on the cable. Thirdly, the use of nails or screws to secure the cable to the Adobe can damage the insulation. To mitigate these risks, it is recommended to avoid installing an M cable in direct contact with the Adobe material. If it is necessary to install an M cable in contact with Adobe, follow these guidelines. Firstly, use only an M cable that is rated for use in wet locations. Secondly, protect the cable from physical damage by installing it in a conduit or by using a cable protector. Thirdly, inspect the cable regularly for any signs of damage. Consider using other types of wiring, such as NC cable or rigid conduit, which are more suitable for use in straw-walled structures. When dealing with electrical installations in unique building types like straw-walled structures with Adobe, understanding the specific risks and code requirements is crucial. An M cable, while commonly used in residential wiring, has limitations when exposed to moisture and physical stress. The National Electrical Code, or NEC, specifically Section 334.12 A10, addresses the use of NM cable, often referred to as non-metallic sheath cable, in Adobe. It essentially prohibits embedding an M cable in Adobe. However, the code does allow for an exception. An M cable can be in contact with Adobe if two conditions are met. Firstly, the Adobe is not likely to be disturbed, and secondly, the cable is protected from physical damage. Let's break down why these restrictions exist and what you should consider when inspecting or designing electrical systems in these types of buildings. The primary concern with Adobe is its moisture content. Adobe is a natural building material made from earth, often including clay, sand, and straw. It can absorb and retain moisture, especially in humid climates or if not properly protected from the elements. An M cable, while having a non-metallic sheath, is not designed for continuous exposure to moisture. Prolonged contact with damp Adobe can lead to the deterioration of the cable's insulation. This deterioration increases the risk of electrical shorts, ground faults, and ultimately, fire hazards. Additionally, the alkaline nature of some Adobe mixtures can chemically attack the cable jacket and insulation over time. Adobe structures are also prone to cracking and shifting due to settling temperature changes and seismic activity. These movements can put physical stress on the NM cable, potentially causing it to stretch, bend, or even break. If the cable is rigidly attached to the Adobe, these stresses are amplified. Damaged cable insulation due to physical stress can create the same hazards as moisture damage, electrical shorts, ground faults, and fire risks. Fastening an M cable directly to Adobe using nails or screws presents another set of problems. It's very easy to inadvertently pierce the cable's outer jacket or insulation when driving fasteners into Adobe. Even small punctures can compromise the cable's integrity and create pathways for moisture to enter. Given these concerns, the best practice is to avoid direct contact between an M cable and Adobe whenever possible. Here are several strategies to achieve this. Firstly, use alternative wiring methods. Consider using wiring methods that are more resistant to moisture and physical damage, such as metal-clad cable, also known as MC cable, or rigid metal conduit, also known as RMC. MC cable has a metallic sheath that provides excellent protection against physical damage and some degree of moisture resistance. RMC offers even greater protection and is suitable for both wet and corrosive environments. Secondly, create an air gap. If an M cable must be used, create a physical barrier between the cable and the Adobe. This can be achieved by installing the cable within a non-conductive conduit, such as PVC, or by using standoffs to maintain an air space. Thirdly, use appropriate fittings and boxes. When transitioning from one wiring method to another, or when connecting to electrical boxes, use fittings and boxes that are rated for the environment. For example, if the location is considered damp or wet, use watertight fittings and weatherproof boxes. Fourthly, dirt opacity. When an NM cable is installed in conduit or is surrounded by insulation, its ampacity or current carrying capacity must be derated according to the NEC. This is because the insulation restricts the cable's ability to dissipate heat, which can lead to overheating and premature failure. Consult NEC Table 310.15. B3 are for ampacity correction factors. Fifthly, conduct regular inspections. Electrical systems and Adobe structures should be inspected regularly, especially in areas where the NM cable is in close proximity to the Adobe. Look for signs of moisture damage, such as discoloration, corrosion, or swelling of the cable jacket. Also, check for any physical damage, such as cracks, abrasions, or punctures. If any damage is found, the cable should be replaced immediately. Let's delve deeper into the alternative wiring methods that are better suited for Adobe construction. Firstly, metal-clad cable or MC cable consists of insulated conductors enclosed in a flexible metallic sheath. This sheath provides excellent mechanical protection against physical damage, making it a good choice for areas where the cable might be subject to impact or abrasion. While MC cable is not inherently waterproof, it offers better moisture resistance than an NM cable. There are also specialized types of MC cable that are designed for wet locations. Secondly, rigid metal conduit, or RMC, is a heavy-gauge steel conduit that provides the highest level of protection for electrical conductors. It is suitable for both indoor and outdoor applications and can be used in wet, corrosive, and hazardous locations. RMC is installed with threaded fittings, creating a rigid, watertight system. Thirdly, intermediate metal conduit, or INC, is similar to RMC but is made of thinner gauge steel. It offers good protection and is lighter and easier to work with than RMC. IMC is also suitable for wet locations when installed with appropriate fittings. Fourthly, electrical metallic tubing, or IMT, is a thin-walled steel conduit that is commonly used in residential and commercial buildings. It is lighter and less expensive than RMC and IMC, but it does not provide as much physical protection. EMT is generally not suitable for wet locations unless installed with watertight fittings. When selecting a wiring method, consider the specific environmental conditions and the level of protection required. In areas where moisture is a significant concern, RMC or specialized MC cable designed for wet locations are the best choices. In dry areas where physical protection is the primary concern, MC cable or EMT may be adequate. In addition to the wiring method, the type of electrical boxes and fittings used is also important. In wet locations, use weatherproof boxes and fittings that are designed to prevent moisture from entering the electrical system. These boxes typically have gaskets and seals to create a watertight enclosure. Also, use corrosion-resistant materials such as stainless steel or aluminum for boxes and fittings that are exposed to the elements. Proper grounding is essential for electrical safety in all buildings, but it is especially important in Adobe structures due to the potential for moisture and ground faults. Ensure that the grounding system is properly installed and maintained according to the NEC. This includes grounding all metal enclosures, such as electrical boxes and conduit, and providing a grounding electrode system that is connected to the earth. Regularly inspect the grounding system to ensure that all connections are tight and free from corrosion. The NEC provides detailed requirements for grounding and bonding in Article 250. Staying up to date with the latest edition of the NEC and any applicable local codes is crucial for ensuring electrical safety. Building codes and standards are constantly evolving to address new technologies, materials, and construction practices. Familiarize yourself with the specific requirements for Adobe construction in your area and consult with a qualified electrical inspector or engineer if you have any questions. Before starting any electrical work, always disconnect the power to the circuit at the main service panel. Use a voltage tester to verify that the circuit is de-energized before touching any wires or components. Wear appropriate personal protective equipment such as safety glasses and gloves to protect yourself from electrical hazards. If you are not comfortable working with electricity, hire a qualified electrician to perform the work. Incorrect wiring can create serious safety hazards, including electrical shock, fire, and equipment damage. Ensure that all electrical work is performed by a licensed and insured professional who is familiar with NEC and local codes. When inspecting an existing electrical installation in an Adobe structure, pay close attention to the following. Firstly, check for any signs of moisture damage, such as discoloration, corrosion, or swelling of the cable jacket or insulation. Secondly, look for any physical damage, such as cracks, abrasions, or punctures in the cable or conduit. Thirdly, verify that the wiring method is appropriate for the environment. If an NM cable is used in a wet location, it should be replaced with a more suitable wiring method. Fourthly, ensure that all electrical boxes and fittings are weatherproof and corrosion resistant. Fifthly, check the grounding system to ensure that it is properly installed and maintained. Sixthly, look for any signs of amateur or improper wiring. If you find any issues, recommend that the electrical system be evaluated and repaired by a qualified electrician. In conclusion, while an NM cable can be used in some limited situations in Adobe construction, it is important to carefully consider the potential risks and take appropriate precautions. The best practice is to avoid direct contact between NM cable and Adobe whenever possible, and to use wiring methods that are more resistant to moisture and physical damage. Regular inspections and maintenance are also essential for ensuring electrical safety in Adobe structures. By following these guidelines and staying up to date with the NEC and local codes, you can help to prevent electrical hazards and protect the safety of occupants. The NEC is not the only resource available. An FPA 73 standard for the installation and use of protective signaling systems, and ICC 500 standard for residential buildings using Adobe rammed earth and straw clay, may provide additional guidance and requirements.